will not change, okay, regardless of how we do our rounding, right? Okay, so this is a number that might change, and this number changes depending on this number over here. Okay, so the digit over here, if it is more than or equals to 5, we will actually round up, okay, such that it becomes a 4. Alright? Then after that, if the digit over here is less than 5, we will round down in the sense that we maintain it as 4. Do we agree at this point? Any questions? Maybe I don't see anything on the table. Okay, can you please prepare yourself. Alright, so the digit over here can actually either be a 3 or a 4. Okay? So when 3, the number over here must actually be more than or equals to 5. Okay, in order for the 3 to round up to become a 4 over here. Yes, let's see. Yes, okay, but I'm trying to get an idea first. Okay, so we are looking at the different possibilities. I'm not trying to answer this question yet. Okay, so we need to first understand what are the possible rounding off. Okay, so this digit here can either be a 3 or a 4. Okay, it can only be a 4 if you actually end up this number here is less than 5. So that 4 is being rounded down to achieve this. Okay, do we understand this concept first? The remaining digits over here doesn't matter. Okay, because it doesn't influence how we do our rounding off. Ethan and Ethan, keep a conversation. End your conversation. Okay, so we have these possibilities. Now, in part A, the question is asking for largest possible. So between 3 and 4, right? Okay, the largest possible would definitely have to come from 4 itself. Okay, so that means we're looking at the original number being rounded down to achieve this 17,400,000. Okay, so if you're going to be rounding down, that means by this digit must be anything less than 5. But we're trying to get the largest possible. Less than 5 means that it can either be 0, 1, 2, 3 or 4. Okay? We want largest possible, so which number should we choose? 4, right? So we choose a 4 over here. Okay? And then by remaining digits, okay, we want largest possible, we should choose a 9. So that's why, okay, for largest possible, our answer should be 17,449,999. Okay? Any questions? Right? Then, in part B, we want to find the smallest possible. Alright? So actually, for these two questions, no working is required. for it is really purely dependent on how you choose the numbers. Okay, no working, just give me the answer for 2 already. Okay. Okay, then after that, in practice now 2A, rounding off to 1 decimal place, I think it's not an issue. However, I did see that rounding to the nearest 0.001 was a little bit of a concern. Okay. So looking at practice now 2A question 1, I just want to look at part D. Okay. Okay, part D was asking to round it to 0.001. Let me find my question. Yep. Okay. So 0.001, where exactly does the decimal place end? It's 3 decimal places, right? So what this question wants, okay, is to round it off to 3 decimal place. 1, 2, 3. Third decimal place is at the 9. Okay. We look at the digit after that. It is a 5. So do we round up or down? Up, right? Okay. So 9 round up becomes a what? It becomes a 10, okay, or a 0. So that means by 10, my 6 over here needs to go up by 1 value itself, so must be 7. So my answer will be 78.47. But I must ensure that the place value remains the same because we want 3 decimal place. So it should have a 78.470. So in order to present your answer, okay, we will write 78.4695 approximates to 78.470, and then this is nearest 0.001 as per what the question was. Okay? So if you are not sure why you don't have a notebook on your desk, okay, questions? Alright, so I do expect that the working, okay, and the answers to all the questions that you do for SLS to already be in your notebook itself. Okay, otherwise you don't have many things to go and revise if you don't have any of such materials. Okay. Now, next one, this question. Okay, looking at practice now 2A question 2. Okay, can I erase this already? Not yet. Okay, now I'll just erase this side up. When rounded off to 2 decimal places, because it thinks that 8.40 is the same as 8.4. I want us to take a look at the responses from everyone in the class. Okay. So these are the responses that I got. I erase the whiteboard already. Okay. There are some of you who put disagree, some of you who put agree. Okay, I selected a few already. Okay, so see, Lucas K and Hanshan says they disagree, but then we have a few who says agree. And those who say agree is because they say 8.4 is the same as 8.40. Technically it's true, right? $8.40, 8.4 and 8.40 seems like they are the same in value. Okay, however, we have people, okay, who also disagree because whatever Lucas says, we may need to find 2 decimal places, so 8.40 is the only correct option. Okay, whereas Hanshan also says something similar because the question is asking for 2 decimal places, so we still have to leave 2 decimal places as 8.40 equals 8.4. Okay. Okay, so I think that the correct answer what should it be? Should it be disagree or agree? Should be disagree, okay? Because like what they rightfully pointed out, question asks for 2 decimal place. If you put as 8.4, is it 2 decimal place? It is not answering the question, right? Okay, so therefore, to answer this question, I'll write down my answer on the whiteboard that I'd like you to copy so that you learn how to explain. Okay, so I disagree because 8.4 is rounded off to 1 decimal place. While 8.40 is rounded off to 2 decimal places. So the answer should be 8.40. Okay. Okay, so I would say that Hanshel's and Lucas' answers are there, so they are correct. Then for them. Okay, so maybe like, for example, answers like Xuan's one. Okay, I disagree because we mean these 2 decimal places when rounding off. So this answer that Xuan has is a little bit lengthy because you never tell me which one is 2 decimal place, which one is 1 decimal place. So do specify, okay? Put in the exact number that is 1 decimal place, then the exact number that is 2 decimal place. Okay? Is also very clear. Okay, so I will accept this answer as well. Okay. Okay, I'm not particular about the spelling and all that now. Okay, I know that typing might be difficult for some of you, so. Questions? Alright. So that rounds up our section 2, okay, or the activity 2 in this chapter 3.1. When it comes to rounding off, okay, numbers to rounding off whole numbers and decimal numbers. Okay. Now I recognize that the challenge that many of you have is in terms of significant figures. Okay. So you all managed to fill out the worksheet that I gave you. Okay, you all have the worksheet? Yes. You couldn't get the video. Was your video loud enough? Oh no. Okay, sorry, my laptop now don't have the sound thing. Okay. I'm sorry that it's very soft. Okay. But actually there is sound one. Okay. No subtitles. Is there subtitles? Fast. It may not be accurate. Okay. I tried my best to make the video. Okay, so I'm sorry if it doesn't work on your laptop, but there's definitely sound. Okay. So I want to. Okay, let me see. How many of you didn't manage to hear the video? Give me some hand. Other than Faith, anybody else didn't manage to hear the video? Okay, I'll just summarize. Okay, I will not be able to go through everything, otherwise we'll be wasting a lot of time. Okay. Let me. Maybe if you're going to skip video, I'd rather you skip out of this class. Okay, you're not going to be doing my lesson properly. I hear what you say very well. open up my PowerPoint slides. Okay, so now I just summarize our 5 different rules. Okay, the first rule when it comes to significant figures is that when I have numbers they are not zero, okay, the digits are not zero, okay, I will naturally count them as a significant figure. So for example, 192, 1, 2, 3 digits over here, they are all not zero, so therefore there are 3 significant figures. An important idea about significant figures is that they must be important, because that's the meaning of significant. Okay, they must be important. Alright? So for example, like even my significant other in my life is my husband. He is an important person in my life, right? Okay, so that's why that's the meaning of significant. Okay. Then 83.761, all these digits are not zero. I also count. Okay, therefore there are 5 significant figures, 1 significant figure, and then 2 significant figures. So that's our rule number 1. I'll show you the rule later on. The next thing is about when there are zeros. Okay? Now, zeros can appear in many places, okay, in a number. When it comes to a decimal like this, 1.09, okay, this zero appears in between 2 non-zero digits. Okay, so we count them in. So therefore I count 1, 2, and 3. So therefore there are 3 significant figures. Okay? Whereas for this one, the zeros appear in the decimal, but it appears right at the beginning, okay, before the 1 over here. When it is in this kind of manner, okay, what I will do is that this I will count as, I will start counting from here, the first non-zero digit, so first, second, and third, therefore 3 significant figures. Okay? And then the last one, okay, I want us to see that the zero appears before and after. Okay, so then which one do I count? So based on this concept over here, the zeros that are at the starting, we never count. Okay, so I don't count here. I only start counting from after the first non-zero digit. That is the 5 over here. Okay, so I'll count from here, but then after the 5, it is actually a 0. Okay, because I intentionally write it there, that means it must be important. Okay, because otherwise I could have just put 0.05, isn't it? Because 0.05 is the same value as 0.0500, right? But for the fact that I wrote it there, it must be important. That's why the answer for the number of significant figures over here will be 1, 2, 3, 3 significant figures. Okay? So with that idea, just want to do a quick check. For these digits over here, can you tell me how many significant figures are there in 3.002? Let me just pick someone. Brandon is not here. Xavier. How many significant figures are there in 3.0024? Sorry? 3? Do you agree with that? No. 6. 5 or 6? 5, right? So we count 1, 2, 3, 4, 5. There should be 5 significant figures over here. Okay? What about 0.10908? How many are there? Let's choose another person. Zach? Zach, how many significant figures are there? 5. Okay? So we don't count this 0. We count this one. 1, 2, 3, 4, 5. Okay? It's not really purely counting, okay? Next one, 0.10. How many significant figures are there? Kyra? 2. Okay, so we count the 1 and the 0. There are 2 significant figures. Okay? So if you didn't manage to fill out the worksheet, I do hope that you fill out the worksheet. Okay? So let me erase that. Then we have 5062. Okay, how many significant figures are there in this number? Let's see, Joshua. How many SF? How many significant figures? 4. Okay, so 1, 2, 3, 4. 4 over here. And then the next one, Colin, how many significant figures are there? 5, you sure you count again? Where do you start counting from? Which digit do I start counting from? I start counting from the 6, right? So 6 onwards, how many digits are there? 4, so there should be 4 significant figures. Get it now? Okay. Next one, 61090. Okay, let's see how many significant figures? 4. Okay. Then 70.8001. You share how many significant figures are there? Okay, you share is there. Share is there, right? Okay, yes. 6. Okay. 1, 2, 3, 4, 5, 6. Okay. 0.021. How many significant figures are there? Faith. 2. Is it? Yes. Okay. And then finally, 41.0320. How many significant figures are there? Kaylin? 6. Okay. 1, 2, 3, 4, 5, 6. Alright. So we go with the counting now. Yeah. So in summary, right? Okay. These are the 4 rules that I hope that you can already copy down. Okay. Okay, all non-zero digits are significant. Zeros, they are in between non-zero, they are considered significant. We count them. Decimal, zeros that are before in the decimal place we don't count, but if it happens after, we count. Okay? So that's our 4 rules. Okay? Yes, there are 5 rules. So then the 5th one is the one that I think many of you have problems in because I saw the whole that you gave me. Okay? It is about whole number. So I just really want to address this. Okay, so I want us to pay attention to this. Now, for whole numbers and there are zeros over here, whether we count them as significant or not, it really depends on the question. Okay? So what this means is that this one, I can call this 2 significant figure because I count a non-zero. Okay, 3 and 8 I must count. Okay, I can either be 2 or maybe I count this 0 so become 3, or I can also count it as 4. Okay, so why is it that over here I write 3 significant figures? It is because the question said that this number was rounded to the nearest 10 meter. So what does that mean? It means that the original number, for example, can be 3,796 meters. And then the question asks you to round it off to the nearest 10 meters. So the 10th position is over here. That is a 9. So 9 we need to round up or down in this case. We round up, right? Because this is a 6. So 6 causes the 9 to round up. And 9 round up become a 10. So my 7 will have to become a 8. Okay? So actually I'm rounding up to this position over here. Okay? That means that the significant figures that I have will be first, second, and third. So there are 3 significant figures in this case. So looking at this, it will tell me where do I count until. Okay? So I need to count up to here. So that's why I only count it as 3 significant figures. You understand me? No? Okay, we go one more example. Okay? We look at the next one, 25,000. Okay? So 25,000.458 is the original number. And I want to round it off to the nearest kilometer. That means I round it to the nearest whole number. So to round to nearest whole number, I will round it up to here. I look at the next digit, which is a 4. So I will be rounding up or down. Down, right? So when I round down, that means this maintains as a 0. I don't need these digits here already. So my answer upon rounding off will be 25,000. Okay? So because I round off up to here, according to what the question wants, so when I count my number of significant was to round off until here. So that's why I count all of this as significant. Okay? Last one, 100,000 grams. The original number, for example, is 98,576. Question wants us to round off to 10,000. The 10,000 place is over here. Okay? So I look at the next digit, it is an 8. That means my 8 will cause my 9 to round up or down? Up. So my 9 will become a 10. Okay? So that's why this 9 here becomes this 10 over here. Okay? But then we are rounding to the nearest 10,000 and the 10,000 place is actually over here. Okay? So I will only count 1 and 0 as my significant figures. I don't need to count the remaining zeros. Get it now? Okay? Maybe I give one extra example. Okay? Same thing now. I tell you I have 100,000. And I say that 100,000 is rounded off to the nearest 100. Okay? I have 5 zeros over here. Can you tell me which zero, the first one, second one, third one, fourth one, or fifth one, which zero is in the hundreds place? Okay? Let me ask the person, Zi. Okay, tell me which zero, first, second, third, fourth, or fifth, is in the hundreds place? The third one, right? Okay? So do we all agree that the third one is at the hundreds place? So that means that when I count the number of significant figures for this number, I will count 1 significant figure, 2, 3, and 4 significant figures. So in this context, I will have 4 significant figures. We can use SF to denote the two words. Okay? Don't need to write it out in full. Just like decimal place, we replace it with the acronym DT. Significant figures, we use SF. Okay? Alright? Are we more familiar with this now? Shall we do one more example? Okay? Same number. Okay? But now I want it to be rounded off to the nearest 10. Okay? Right, we want it to nearest 10. Yes, Francis. Yes, okay. Yes, Sylvia. Okay, repeat. What is it? Count only until where it asks you to round off. Okay? Okay, so nearest 10, which zero, okay, is at the 10th position? Okay? Joel is not here. And then Elena. Okay? Which zero is at the 10th position? The fourth one, right? Okay? So that means I will count until here. Okay? So therefore there are 1, 2, 3, 4, 5 significant figures when it is rounded to the nearest 10. You understand now? Okay? So this means that for the number 100,000, I must surely count the 1 because it is not a zero. But the remaining zeros itself, it depends on what the question says. Okay? So the counting of the zeros, the inclusion of the zeros, really depends on what the question says for us to decide. That means that my 100,000 can range from 1 significant figures to the maximum of 6 significant figures because there are 6 digits after all. You understand now? Are we clear about this? Okay, if you're good, okay, so this is the rule number 5. Okay, I don't expect you to go and memorize word for word all these rules. You just need to really practice and have it at the back of your head. Okay, when it comes to rounding off. Alright? So, if you're clear about it, okay, I want us to just answer these figures. Okay, and open up my fingers, alright? Okay, how many significant figures are there in this number? Can you help me with that? Is your answer not his answer? Yes, sorry. Okay. Anybody else? Okay, Francis. Lucas. Lucas, just now you raise up, right? What do you raise up? Yeah, I said it's can you raise up again? No. Okay, can. Anybody else? John already done, right? Okay, okay. Kira, how about you? Kyra, sorry, this is too confusing for me, yes. You did your notebook, then Ziyi. Sorry, can you raise it higher? Not scared already, oh, okay. What else? Common? White? Okay, then, alright. I cannot accept that you all have your notebook, okay? Otherwise, I don't know what you're writing, where you're writing it. Okay, so let's see the answer. All of you give me 5, okay, and that is the correct answer. So that's great. Okay, that means all of you are getting it. Oh, I didn't know there's something back. Okay, let's look at the next one. Okay. Okay. Alright, so let's see. All of you also choose 5. Okay, and that is the correct answer. Okay, so that's great. Okay, so we start counting from here. Next one. Okay, 3000.15. How many significant figures are there? Okay, we done? Let's see. Don't worry. Any decision or not sure? So you're not sure, is it? It's not sure. Okay, now don't worry. Okay. So let's see. We do have people who say that the answer is 5. So let's count. Okay, what exactly is the answer? So these zeros over here are in between non-zero numbers. Okay, so therefore we count 1, 2, 3, 4, 5, 6. There should be 6 single figures. Okay, so the correct answer is actually D. Okay, I hope this clarifies. So you get it ready? Understand now? Okay, next one. 703.0. How many significant figures are there? Okay. Okay. Any more? Okay. Now let's see. There seems to be a variety. Okay, someone tell me 3, someone tell me 4. I don't know who will give me 5. Okay, maybe it was a mistake by written. Okay, so yeah, I don't know who gave me 5. According to my phone, Zach gave me 5.
I put wrong.
Put wrongly, okay, now mine. Okay, so what did we say about this 0? Because we purposely put it there, that means that it must be significant. So therefore, we count 1, 2, 3, 4. Okay, so therefore the answer is 4. Okay, so a number of you chose 3. I hope it clarifies that this should be 4. Okay, last question. How many significant figures are there in 6,200? Okay, that means can be 2, 3, 4. indefinite. That means there are many possibilities, right? Okay. All the above, that means it can be 2 significant figures, can be 3, can also be 4. These options are there. Okay, any more? Joshua? Can't decide? Need more time? Okay, 10. Let's see. Okay, some of you say 2, some of you say 4. Actually, those who say 2, you're not wrong. Those who say 3 also not wrong. Say 4 also not wrong. Okay, because this question never say rounded to what, right? Okay, so like I mentioned earlier, like for example, 100,000, it can be considered 1 significant figure, 2, 3, 4, or 5 significant figures, or even up to 6. So in this case, for this number, okay? So in this case, I have 1 and 2, 6, 2 must count. The 0, it depends on the question. So it can be either 2 significant figures, 3, or even 4 significant figures. Okay, so the answer is actually D or the above. Okay, because those are the possibilities. This question didn't specify it. Alright, questions? Okay, are we clearer about this now? Okay, so let's go back. Okay, so if you're clearer, you may want to go back and try the questions, okay, in the SLS again. Okay. Now, something that I want to clarify, I think I made a mistake in one of the answers. Okay, but I think question 2 was a problem. Okay, generally. So let's look at this question. Okay, this is in your textbook page, hang on. Okay, sorry, this one is not textbook. Like that, this one is I'm doing myself. Okay. So look at this question. It says that 55,300 has been rounded to the nearest 1,000. So we have 55,300. Okay, state the number of significant figures that it has. Where is the thousands place? Which digit is it? The first 5 or second 5? It's the second 5, yes, it's the. Yes, correct. So that was my mistake in this question. Okay, I overlooked this question, okay, because the thousands place is at the 5, so this was incorrect rounding in the first place, so that was my mistake. Okay, so I just want to correct this question, okay, to round it to nearest 100. Okay, so if it's rounded to nearest 100, okay, that means my 100th position is 3. Agree? Okay, so that means how many significant figures would there be? Jin Jin, you want to give this a try? There will be 3 significant figures. Colin, you agree? You agree? Okay, then maybe Emmanuel, you agree? Okay, so we agree that there are 3 significant figures for this question, so the answer is 3. Okay, I'm unable to go and correct this, okay, because I sent out the assignment already. I just want to correct the mistake I made. Okay, now question 3. We have the number 534,000 rounded off to the nearest 10. Okay, which digit is in the 10th position? Evan. Which digit is in the 10th position? 2? 10th, you see, read the question. Nearest 10. See, either you keep talking to him, then you don't know anything. Which 0? There are 3 zeros. The middle one. Okay, yes. So, we stop counting over here. How many significant figures are there in this question? Rose? Rose, how many significant figures are there? 5. Okay, so there are 5. So we count 1, 2, 3, 4, 5. Okay, so 5 significant figures. Okay. Next, question 4. 12813. Rounded to the nearest 1000. Most of you can give me the correct answer. What would that be, Carmen? Nearest 1000, what would it be? 13,000. Okay. Alright, so now looking at 13,000, we want to see how many significant figures are there. Okay, to this question. So, Trina, can you tell me how many significant figures are there? Nearest 1000. 2. Okay, so nearest 1000 was round up here, so therefore there are 2 significant figures to this number. Okay, I hope that we are clear about this already. Alright, because that's the end of my SLS lesson. Okay. I hope I address all the concerns that you all have made. There are some concerns, okay, when answering this question telling me about past chapters. I'll address it after I mark the WA now. Okay? Okay? So, if that's the concerns that we have for SLS, okay, my lesson end what time? 10:30, right? I only got 5 minutes there. Okay, let's do a little bit of question. Let's do one question, okay? Let's learn how to round off. Okay, let's look at practice now 3, that's in your textbook, page 78. Following to the number of significant figures given in the brackets. So we have the number 3748. To round off to 3 significant figures, that means that I need to first know where does 3 significant figures end. So this is the first, second, and third. That means that I need to round off up to here. Okay? And the next digit is actually a 8. So do we round up or down? Up. Okay? So if I round up it is, can you tell me what would the answer be? I'm rounding up. I want to round off 3 significant figures. This is my first, second, and third. Round up will become 3, then 3, 7, 5. We need a 0? Okay. Yes, very good. So this will make 3 significant figures. Okay? What if I don't write the 0? Because the question says 3 significant figures. Yeah, okay? So if I don't put the 0, this becomes 375. But the original number is 3,748. Okay? You cannot such that when you round off, the value changes. So this 0 is important to put it there for place holding purposes, okay, to maintain the same place value. Alright? So this 0 we don't count it as a significant figure, but we must have it there. Just like how we round off whole numbers and decimal numbers earlier on. Okay? So the answer will be 3750 to 3SF. Okay? Next one, part B. Okay, we have 0.04700989. We want to round off to 4SF. Okay, 4 significant figures. Alright? Anybody would like to try? No? They are called name. Sagan, can you tell me which digit is at the 4 significant figures? This 9? Okay, so we count. This is 1, 2, 3, 4. So this is where I need to round off until I look at the next digit. Okay? He already gave you the icon, didn't give you a try. Try it, okay? Nothing wrong with being wrong. We are all here to learn. 9 round up become? Okay, so the 0 become a 1. So I will write 0.00471. Is it? Is that all? You sure? One more 0. Okay. Very good. So you see we got it. Okay, so 4 significant figures. Okay, 1, 2, 3, 4. Alright? The remaining ones I don't need to put 0. Okay? So I'll end my lesson here today. Next week we will continue. Okay?